Hello guys, Samuel here. In this video we are going to be solving the algorithm problem contains duplicates. Let's dive right in. The problem statement reads, given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. Now I'll go ahead to give a visual explanation of the solutions to this problem. Given these two arrays, the problem expects us to write an algorithm that will return true for the first array, and that is because the element 3 is appearing twice. However, the same algorithm should return false for the second array, and that is because every element of that array is distinct. In this video, I'll be implementing 3 different solutions to this problem. Now let's dive into a visual explanation of the first solution. For this first solution, I'll be adopting a brute force approach. So I'll iterate over every element of the array. And for each element under iteration, I'll check if a duplicate exists in the element after it. Once I come across a duplicate, I'll stop iterating and return true. If after iterating over all the elements of the array, I did not find a duplicate, then I'll return false. So for this input array, I'll start from the first element of the array, which is 1, and I'll check all the elements after it for the existence of a duplicate. So I'll compare 1 and 2, they are not the same. I'll compare 1 and 3, they are not the same. I'll compare 1 and 3, they are not the same. Now I'll go to the next element in the array, which is 2, and I'll check every element after it for the existence of a duplicate. So I'll compare 2 and 3, they are not the same. I'll compare 2 and 3, they are not the same. Now I'll go to the next element in the array, which is 3. Now I'll compare 3 and 3, they are the same. So I found the duplicates, my algorithm will return true. But let's assume that for this last element of the array, instead of it being 3, it's 4. And then continue from these points in the array. So I'll compare 3 and 4, they are not the same. Now I'll go to the last element in the array, which is 4. 4 has no element after it, so I'm done iterating. I have not found the duplicate, so my algorithm will return false. The time complexity of this algorithm is big O of n squared. And that is because for each element in the array, I am checking every other element after it for the existence of a duplicate. The space complexity of the algorithm, however, is big O of 1. And that is because I am not using an additional data structure which increases with the size of the input array to store any data. Now let's dive into the second solution to this problem. For the second solution, the first thing I'll do is to sort the input array. After sorting the input array, I'll compare adjacent elements in the array for the existence of a duplicate. When I come across a duplicate, I'll stop checking adjacent elements and I'll return true. But if after checking every adjacent element in the sorted array, I did not come across a duplicate, then I'll return false. So sorting this array becomes an array of elements 1, 2, 3, and 3. Now I'll start comparing adjacent elements starting from the first element in the array. So I'll compare 1 and the adjacent element after it, which is 2. They are not the same. So I'll move to the next element in the array. Now I'll compare 2 and the adjacent element after it, which is 3. They are not the same. Now I'll move to the next element in the array. Now I'll compare 3 and the adjacent element after it, which is 3. Now 3 and 3 are the same. I found a duplicate, so my algorithm will return false. But for this input array, let's assume that the first element, instead of being 3, is 4. So after sorting the array, it becomes an array of elements 1, 2, 3, and 4. Now if we should continue from this same position, I'll compare 3 with the adjacent element after it, which is 4. They are not the same. So I'll move to the last element in the array. Now 4 has no adjacent element after it, so I'm done checking the adjacent elements for the existence of a duplicate. For this particular scenario, I could not come across a duplicate, so my algorithm will return false. The time complexity of this algorithm is big O of n log n, and that is because sorting the input array takes big O of n log n time. The space complexity of the algorithm, however, is big O of 1, and that is because I'm not making use of an additional data structure that increases as the size of the input array increases to store any extra data. Now let's dive into the third solution to this problem. For the third solution, I'll be making use of a set. A set in JavaScript is a data structure that stores only unique elements. So I'll iterate over each element of the input array. For each element under iteration, I'll check if the element exists in the set. If the element already exists in the set, it means I've found a duplicate. So I'll stop iterating and I'll return true. If the element does not exist in the set, then I'll add the elements to the set. If after iterating over all the elements of the input array, I did not come across an element that already exists in the set, it means the input array contains no duplicates, and my algorithm will return false. So now I'll go ahead to declare an empty set, and I'll start iterating beginning from the first element of the input array. So I'll check if 3 already exists in the set. 3 does not exist in the set, so I'll add it to the set. Now I'll move to the next element of the input array, which is 2. I'll check if 2 exists in the set. 2 does not exist in the set, so I'll add 2 to the set. Now I'll move to the next element of the input array, which is 1. I'll check if 1 exists in the set. 1 does not exist in the set, so I'll add 1 to the set. Now I'll go to the last element of the input array, which is 3. I'll check if 3 exists in the set. Yes, 3 already exists in the set. So I've found the duplicate, I'll stop iterating, and my algorithm will return true. But for these last elements of the array, let's assume it's 4 instead of being 3. And continuing from this current position, I'll check if 4 exists in the set. 4 does not exist in the set, so I'll add it to the set. Now I'm done iterating over all the elements of the input array. I have not found the duplicate, so for this scenario, my algorithm will return false. The time complexity of this algorithm is big O of n, and that is because I am iterating over every element of the input array once. The space complexity of the algorithm is also big O of n, and that is because of the extra space I'm using for the set to keep track of the elements of the input array I have seen so far. And in a worst case scenario where the input array does not contain a duplicate, I would have added every element of the input array into the set. Now let's dive into the code implementation to the second and the third solutions to this problem. For the second solution, the first thing I'll do is to source the input array. Next, I'll iterate over all the elements of the input array up until the second to the last element and check for the existence of a duplicate in adjacent elements. I'm iterating up until the second to the last element because the last element of the input array does not have any adjacent element after it. Now I'll check if the current elements under iteration and the adjacent elements after it are the same. If they are the same, I'll stop iterating and I'll return true. If they are not the same, I'll continue with the iteration. And after iterating over the elements of the array, and I could not find adjacent elements that are the same, it means the input array contains no duplicates. I'll return false. Now let's go ahead to test this code for correctness. It has passed. Let me go ahead to submit. Submission was successful. Now let's dive into the code implementation of the third solution. For the third solution, the first thing I'll do is to declare a set. I'll save the set in a variable called scene. Next, I iterate over every element of the input array. For each element under iteration, I'll check if it already exists in the set. If it does, I'll stop iterating and I'll return true. If the current element under iteration does not exist in the set, I'll add it to the set. If after iterating over all the elements of the input array, I did not find an element that already exists in the set, then I'll return false, meaning the input array contains no duplicates. Now go ahead to run this code for correctness. It has passed. I'll go ahead to submit. This has passed also. That's it for this video. Thank you for watching. If you found this video to be helpful, give it a thumbs up. If you'd like to see more content like this on tech education, subscribe to my channel. And if there's a problem you want for me to solve in an upcoming video, kindly let me know in the comment section. I'll see you guys in the next one. Happy coding.